Hello, I'm Yesenia Sanchez Fuentes. I'm a PhD student. I'm going to present my research work that is titled Synthesis and Characterization of Hybrid Molybdenum Trioxide Carbon Nanotubes Nanostructures. In the last decade, hybrid molybdenum trioxide carbon nanotubes nanostructures have gained scientific and technological interest due to their high electrical conductivity and capacitance, which makes them attractive for application in supercapacitors and catalysis, among other fields. Molybdenum trioxide carbon nanotubes have been synthesized by various chemical and physical methods. However, today there are no reports in the literature of the use of the vapor phase dissociation method to prepare molybdenum trioxide carbon nanotube nanostructures. In the present research work, the synthesis and characterization of molybdenum trioxide carbon nanotubes hybrid nanostructure were carried out by the vapor phase dissociation method. The effect of multi-wall carbon nanotubes, functionalization medium, molybdenum carbon nanotubes, weight ratio, and temperature of the first stage of the vapor phase dissociation method on the structural and morphological characteristics of the hybrid nanostructures were investigated. The experimental part begins with the functionalization of carbon nanotubes used as a template for the growth of the molybdenum trioxide phase. Next, the functionalized carbon nanotubes were subjected to the vapor phase dissociation method for the formation of the molybdenum trioxide phase. Two means for functionalization of carbon nanotubes were investigated called moderate functionalization (FM) using nitric acid solution and severe functionalization (FS) using a mixture of nitric acid and sulfuric acid. Both functionalizations were carried out at 90 degrees for 24 hours. Once the carbon nanotubes were functionalized, a mixture of the functionalized carbon nanotubes with the molybdenum hexacarbonyl precursor was prepared, mixing them for 10 minutes with the help of an agate mortar. The mixture were prepared with different content of molybdenum precursor to propitiate molybdenum trioxide carbon nanotubes nanostructures with different molybdenum content in the final product. On the other hand, the temperature of the first stage of the vapor phase dissociation method was varied 180, 170, 160, and 140 degrees, maintaining a constant 1-to-1 weight ratio. Molybdenum trioxide carbon nanotubes hybrid nanostructures were synthesized by the vapor phase dissociation method, which consists of two consecutive thermal stages that are carried out in a horizontal hot wall reactor. The mixture placed inside a quartz reactor with a porous membrane, which in the turn was placed inside the hot wall reactor. The first stage was carried out for 10 minutes under vacuum conditions of 5 to 7 torr. In the second stage, argon was fed for an additional 10 minutes with a flow of 100 cm cubic per minute, with the purpose of eliminating any vapor or gaseous residue such as CO and CO2 from the reactor, and the temperature was kept at 400 degrees. The resulting product was collected and identified as a molybdenum trioxide carbon nanotubes hybrid nanostructure. The samples were characterized by X-ray diffraction (XRD), transmission electron microscopy (TEM), scanning electron microscopy (SEM), and X-ray photoemission spectroscopy (XPS).